Welcome back, deep divers. Today, we're taking a plunge into the world of supernovae.
Those brilliant cosmic explosions that, for a short time, can outshine entire galaxies.
Yeah, you guys sent in an awesome article all about the physics of these events and why they're so important.
So they are important.
So we're going to break it all down for you.
Yeah, it's a lot to cover.
It is, but it's also super fascinating. So let's start with the basics. We know stars live for billions of years,
Right.
but they don't last forever. What causes these incredible supernova events?
Well, you got to think of a star's life as this delicate balance. You've got gravity pulling everything inward, right?
Yeah, crushing it down.
Exactly. And then you have the outward push from the nuclear fusion happening at its core.
So it's like a constant tug of war.
Exactly. But eventually, the star runs out of fuel.
Okay, so the outward pressure stops.
And that balance is broken. For some stars, what happens is they collapse in on themselves
Oh, wow.
and become these super dense things called white dwarfs.
White dwarfs, I've heard of those.
Yeah, imagine something the size of Earth,
Okay, tiny.
but it's got the mass of the sun.
Oh, wow, that's dense.
Yeah, it's wild.
But how do white dwarfs lead to supernovae?
Well, sometimes a white dwarf is hanging out with another star. It's part of what we call a binary star system.
Okay, so two stars orbiting each other.
Right. And this white dwarf, it starts pulling material from its companion star. It's kind of like stealing its stuff,
Stellar theft.
basically. But as it seals more and more, it eventually reaches a critical mass.
Too much theft?
And then boom, it explodes.
A supernova.
Yep, a Type 1a supernova to be precise. And the cool thing about these Type 1a supernovae is they all kind of explode with the same brightness.
Really?
Yeah, it's wild. And because of that, astronomers use them as standard candles.
Standard candles.
It's like having a measuring stick for the universe. We can use them to measure distances across space.
So the same event that marks the end of a star also helps us understand the scale of the universe.
Exactly.
Yeah,
It's pretty awesome.
that's pretty incredible. But what about those stars that aren't in a binary system? What happens to them when they run out of fuel?
Well, for really massive stars, way bigger than our sun, things get even more dramatic. These stars, they're like cosmic pressure cookers.
Okay, how so?
They're constantly fusing heavier and heavier elements in their cores, but eventually they hit a wall. They can't fuse anything more.
Like they run out of ingredients.
Exactly. The core collapses under its own immense gravity.
Oh no,
And that collapse, it triggers a massive shockwave.
a shockwave.
Yeah, it blasts the outer layers of the star out into space.
And that's a Type 2 supernova.
You got it! A spectacular, brilliant display of cosmic fireworks.
So we have two different ways a star can go supernova. But they both sound pretty intense.
Oh, they definitely are.
And they have different outcomes, right?
Yeah, one of the big differences is what they leave behind. A Type I supernova, poof, it's gone. Just an immense explosion.
Okay, nothing left.
Not much, no. But with a Type 2, it can leave behind a neutron star.
A neutron star.
Yeah, even denser than a white dwarf. Or, and this is the crazy part, it can leave behind a black hole.
Black holes. Those are kind of scary.
They are a bit mysterious, but fascinating.
Definitely. So we have white dwarfs, neutron stars, and black holes, all remnants of these supernova events.
Yeah, it's like a cosmic graveyard.
It's a lot to keep track of. But why should we care about what's left behind?
Well, these remnants aren't just sitting there doing nothing. They actually have a big impact on the space around them.
Okay. In what way?
Take the shock waves from supernovae. They can actually trigger the formation of new stars.
So one star dies and helps create new ones.
And exactly. It's kind of a beautiful cycle, isn't it?
It's like a cosmic domino effect. One star's death can lead to the birth of countless others.
Exactly. The universe is constantly changing. Death and creation, they're all intertwined.
Wow, I never thought of it that way. But aside from helping create new stars, what else do supernovae contribute to the universe?
Oh, well, this is where it gets really, really interesting. Remember how we were talking about Type 2 supernovae fusing all those heavier elements?
Yeah, those cosmic pressure cookers.
Right. Well, it turns out that those events are where most of the elements heavier than iron are made.
Wait, are you telling me the stuff that makes up, well, everything, like us, came from supernovae?
That's exactly what I'm saying.
That's wild.
Yeah, it's incredible, right? Everything, the carbon, the oxygen, even the gold in your jewelry, it was all forged in the heart of a supernova.
So those spectacular explosions are more than just cosmic fireworks. They're the source of the building blocks for, well, everything. That's amazing, but there's even more to this story, right?
Oh, absolutely. We've only just scratched the surface here. Supernovae, they also hold the key to understanding some of the biggest mysteries of the universe.
Okay, like what?
Well, things like how the universe is expanding and this mysterious thing called dark energy.
Wait, I thought we knew the universe was expanding. Isn't that kind of old news?
It is, but here's the thing. By watching Type 1a supernovae in these faraway galaxies, astronomers have discovered that the universe's expansion, it's not constant, it's actually getting faster.
The universe is expanding faster over time. But how is that even possible?
Well, that's where dark energy comes in.
Dark energy sounds a bit like science fiction.
It does, doesn't it? But it seems this dark energy, it's this unknown force that's making up about 70% of the universe's total energy.
70%, that's most of the universe.
It is. And it's counteracting gravity, pushing everything apart at an ever-increasing rate.
Dark energy.
Hmm.
Okay, my mind is officially blown. Supernovae aren't just explosions. They're like cosmic laboratories, giving us clues about the origin of elements, the structure of the universe, and even this mysterious force that's driving its expansion. This deep dive is getting pretty deep.
It really is, isn't it? And it's not just theory, you know? Scientists have developed some incredible techniques to actually observe and study these supernovae, even the ones billions of light years away.
Okay, now that's where I get a little lost. How can astronomers actually study something that happened so long ago and so far away?
Right. We can't exactly travel to a supernova,
Yeah.
but we have some pretty powerful tools. And the most important one, light. By analyzing the light from these explosions, we can learn a ton.
Okay, unlock the secrets.
Yeah.
But how does light tell us anything useful from that far away?
Well, think of it like this. Light is a messenger. It carries information across the vastness of space.
A messenger, okay.
And one way we decipher those messages is through something called spectroscopy.
Spectroscopy. That sounds familiar. Vaguely. High school science class, maybe?
Yeah. Basically, you pass the light from a supernova through a prism.
Okay, like splitting the light into a rainbow.
Exactly. But instead of a simple rainbow, we get what's called a spectrum.
That spectrum.
It's this unique pattern of bright and dark lines. And that pattern acts like a fingerprint
A fingerprint. For what?
for the elements that are present in the explosion.
Oh, wow. So each element has its own, like, color code?
Exactly. We analyze the spectrum, and boom, we know what the supernova is made of.
That's so cool. So we can literally tell what a supernova is made of just by
Mhm.
looking at the light. Are there other secrets hidden in that light?
There are. Ever heard of the Doppler effect?
Um, Vaguely.
It's like how the sound of a siren changes as it gets closer or further away.
Oh, yeah, I know what you mean.
Well, light does something similar. And by looking at how the spectral lines are shifted, we can tell if the supernova is moving towards us or away from us.
And how fast.
Exactly, like
Yeah.
a cosmic speed gun.
We can actually measure the speed of these explosions from billions of light years away.
We can. And another important thing we can measure is the supernova's brightness.
Okay, so how bright it looks.
Well, yeah, but there's actually two types of brightness. There's apparent magnitude, which is how bright it appears to us here on Earth. And then there's absolute magnitude, which is its true brightness, how much light it's actually putting out.
Right, that makes sense. Because something really far away could look dim,
Yeah.
but actually be really bright.
Exactly. And that's where those standard candles come in again. Remember those Type 1a supernovae?
The ones that all explode with the same brightness.
Right. So we know how bright they actually are. And by comparing that to how bright they appear to us, we can figure out how far away they are.
So they're like cosmic yardsticks, measuring the universe.
Precisely. And there's one more piece of the puzzle, light curves.
Light curves.
It's just a graph. It shows how a supernova's brightness changes over time because they don't just appear and disappear.
Right.
No, they brighten, they reach peak brightness, and then they fade away over weeks or even months.
So by tracking that change, we learn even more about the supernova.
We do. The shape of that light curve tells us a lot about the type of supernova, the energy released, and even the environment around it.
Wow. So much information from like a simple graph. It's amazing.
Yeah.
It makes me wonder, how long have people actually been observing supernovae? I mean, way before all this cool technology.
Oh, for millennia. Ancient astronomers, they'd see these new stars appearing, often brighter than any others.
I can only imagine what they thought. A new star suddenly appears. It must have been pretty amazing. It may be a little scary.
I bet. But they didn't really understand what they were seeing, of course. It wasn't until the 20th century that we really started to figure out the physics behind these events.
So what were some of the big breakthroughs that led to our modern understanding?
Well, there's this landmark study from the 1950s, the BFH paper.
Beefy FH. That sounds more like a math equation than a science paper.
Well, it's named after the four guys who wrote it: Burbage, Fowler, and Hoyle.
Ah, okay, four guys.
And what they did was they explained how stars create elements. Stellar nucleosynthesis is called. The process of how lighter elements like hydrogen and helium are fused together to make heavier elements.
So stars are like cooking up new elements.
Yeah, and they showed how the heaviest elements, the ones heavier than iron, are created in the extreme conditions of a supernova.
So literally connecting the life and death of stars to the elements that make up everything.
Exactly. It was huge. And then, remember those type 1A supernovae, the ones we use as standard candles?
Yeah.
Well, in the late 1990s, two teams made a shocking discovery using those very supernovae.
What was that?
They found that the universe's expansion, it's not just happening, it's speeding up.
Right. We talked about that earlier. But just to be sure I understand, how did they use supernovae to figure that out? It seems like a big leap from exploding stars to the entire universe expanding.
It is, but they very carefully measured the distances and redshifts of these supernovae in faraway galaxies. And what they found was the expansion was speeding up, not slowing down as everyone thought it would.
So it's like watching a movie, but the movie's on fast forward.
Yeah, exactly. And that's what led to the whole idea of dark energy as the force behind this acceleration.
Wow. So those supernovae, they weren't just telling us about their own explosions. They were telling us about the entire universe and how it's evolving.
Exactly. It shows just how interconnected everything is, from the smallest atom to the largest cosmic structures.
It really does.
Yeah.
We've been talking a lot about the science of supernovae, but what does it all mean? What are the implications for our understanding of the universe and our place in it?
That's a great question. We've looked at the how, but now it's time for the why. What's the bigger picture here?
Yeah, it really is amazing how these stellar explosions billions of years ago shaped the universe we live in today.
It really is. We talk about supernovae creating those building blocks of matter, but they also have a huge role in, shaping the actual structure of the universe, the large-scale structure.
Okay, how so?
Well, their explosive energy helps to seed galaxies with those heavier elements,
Okay.
creating the right conditions for stars and planets to form, and ultimately life itself.
So they're both creators and destroyers. They end the lives of stars, but they also spark new life.
Exactly, a cycle of cosmic renewal on a massive scale.
Wow, that's pretty amazing. And we're not just learning about the past, right?
Right.
We're also gaining insights into the future of the universe. So what can supernovae tell us about the universe's fate? We've talked about dark energy driving that accelerated expansion, but what does that mean in the long run?
That's the million-dollar question. Will this expansion just continue forever? Will it keep speeding up, or will something else happen, something we can't even imagine yet?
Whoa, okay, big questions. And I'm guessing supernovae hold some clues.
They do. By carefully measuring the distances and redshifts of these supernovae, especially the ones in those really distant galaxies, we can kind of track how that expansion has evolved over time.
So the more supernovae we observe, the better our models of the universe.
Exactly. And the better our models, the more accurately we can predict the future, the universe's future. But even with everything we know now, the ultimate fate, it remains one of the biggest mysteries in science.
It's exciting and kind of scary, right, to think about.
It is. We're living in this universe that's constantly changing.
Yeah.
And we're only just beginning to understand the forces that shape it.
It really makes you feel small, doesn't it?
It does. Here we are on this tiny planet orbiting an average star in this vast universe. But by studying supernovae, we get to glimpse the grand history of the cosmos, from its fiery birth to its eventual destiny.
I'm starting to understand why you're so passionate about this. It's more than just science. It's about connecting to something much, much bigger than ourselves.
You got it. For me, studying supernovae, it's about exploring those really deep questions, the existential ones, like where do we come from? Where are we going? What's our place in all of this?
It's incredible how these distant explosions can make you think about such huge things. As we wrap up this deep dive into supernovae, what are some key takeaways you want our listeners to remember?
Well, I hope they come away with a sense of awe, appreciate the power and beauty of these supernovae.
Yeah.
They really are a spectacle, a reminder that the universe is dynamic, it's full of surprises, and I also hope they understand the crucial role they play in that cosmic cycle of life and death. Supernovae, they aren't just destructive, they're creative too. They seed the universe with those elements that make life possible.
It's mind-blowing to think that the atoms in our bodies were once part of those explosions. We really are made of stardust.
We are, and last but not least, I hope they understand the implications supernovae have for our understanding of the universe. Its history, how it's evolving, and where it's all going.
It's been a truly illuminating deep dive.
Yeah.
I feel like I've gained a whole new appreciation for these cosmic fireworks.
That's great to hear. But remember, this is just the beginning. There's so much more to learn and explore out there.
So true. To our amazing listeners, keep those minds curious and keep looking up at the stars. You never know what you might discover. And if you ever find yourself pondering those big questions about the universe, remember that even the most distant supernova can shed some light on our existence. This has been The Deep Dive, and we'll catch you next time for another fascinating exploration.